Hey, 7th grade. In this next lesson, we're going to talk about the third form of a linear equation, which is called standard form. If you'll recall, the first two forms we looked at were slope-intercept form and point-slope form. And so today we're going to look at this last form and investigate some of the things it tells us and how to graph an equation written in this form. A couple of vocabulary terms. One I want to review with you. First of all, y-intercept, that's a term we've already seen before in this unit. Just to recall, the y-intercept is a point, okay, so you write it as an ordered pair, the point where a graph crosses the y-axis. Okay. We also have what's called an x-intercept, and so it makes sense logically that if the y-intercept is the point where a graph crosses the y-axis, then the x-intercept would be the point where a graph crosses the x-axis. And so when we're dealing with standard form, a lot of times we talk about both x and y intercepts because we're going to find that when you're given an equation in standard form, you're able to find the x and y intercepts rather quickly. Okay, so this is what standard form looks like. If you look down here in this box, standard form of a linear equation is written in this format: ax plus by equals c. A, B, and C are all integers, so that means there are no fractions when you're in standard form. You have all whole numbers, and A and B are not both 0. Okay, so it looks a little bit different from the other two forms we've seen before. The key is you do not have fractions in standard form, and x and y are on the same side of the equal sign, basically. So we're going to practice, first of all, finding x and y intercepts when you're given an equation in standard form. Okay, and again, remember, standard form has no fractions. So if you think about a point on the x-axis, okay, a point on the x-axis, so I'm just going to draw a quick little sketch here of a graph. Okay, here's my coordinate plane, and here's my line. Okay, the x-intercept of that line would be about right here, wherever that line's crossing the x-axis. Well, every single point on the x-axis, whether you're right here, or whether you're right here, or whether you're right here, okay, no matter where this x-intercept is, every single point on the x-axis is going to have an ordered pair that looks like this: something, comma, 0. Okay, the y-coordinate, anytime you're on the x-axis, is always going to be 0. So we're going to find that if we want to know what the x-intercept is, all we have to do is substitute 0 for our y value, and then we can solve our equation for x. Okay, so if we plug in a 0 for y, that allows us to find the x-intercept whenever we're given an equation. And the same is true to find a y-intercept. If you think about where the y-intercept is on this graph right here, that would be this point right here. And the ordered pair for that point is going to be 0, comma, something. Okay? And that's going to be true of every point on the y-axis. No matter where that y-intercept is, the x-coordinate will always be 0. So to find the y-intercept, you're going to substitute a 0 in for x to your equation, then solve for y. Okay, so the point is this: anytime I give you an equation and you want to find the intercept, either the x or the y, you always substitute a 0 in for the opposite variable. Okay, so we're going to practice this now in examples 1 and 2. For each of these equations, we're going to find the x and y intercepts of the graph, and we're going to keep in mind that when we're finding x and y intercepts, we are finding points, and so we need to list these as ordered pairs. Okay, we're not finding slope for these, we are finding two separate points. So number 1, we have 3x plus 4y equals 24, and the first thing I'm going to find is I'm going to find the x-intercept. Okay, so to find the x-intercept of this line right here, what I can do is I can substitute 0 for my y value, because I know the y-coordinate of the x-intercept has to be 0. So I'm going to take the equation 3x plus 4y equals 24, and I'm going to assume y is 0. So that's going to give me this: 3x plus 4 times 0 equals 24. Well, 4 times 0 is just 0, so really I get this on the left side. I get just 3x equals 24. And so now I can solve this equation by dividing both sides by 3, and that tells me x equals 8. So that means that my x-intercept, okay, this line crosses the x-axis at 8, 0. Okay, now I'm going to find the y-intercept. To find the y-intercept, I'm going to take the equation. This time I'm going to plug in a 0 for x. Okay, I know if I'm on the y-axis, then my x-coordinate has to be 0. So this is going to be 3 times 0 plus 4y equals 24. 3 times 0 is just 0, so the left side just becomes 4y equals 24. If I divide both sides by 4, I get y equals 6. So that means that the y-intercept of this line is the point 0, 6. Okay, so we found both x and the y-intercept on this line. The x-intercept is at 8, 0. The y-intercept is at 0, 6. Okay, now we're going to try number 2. This time the equation is 2x minus 5y equals negative 6. So to find the x-intercept for this line, I'm going to take the equation and I'm going to substitute a 0 for my y value. So 2x minus 5 times 0 equals negative 6. That's going to give me 2x equals negative 6, and so x equals negative 3. So that means my x-intercept is at negative 3, 0. And now to find the y-intercept, I'll take the equation again. This time I'll plug in a 0 for x. So 2 times 0 minus 5y equals negative 6. That gives me negative 5y equals negative 6. And so if I divide both sides by negative 5 for this one, I'm actually going to get a fraction. Negative 6 divided by negative 5 is 6 over 5. Or you could also write that as 1.2. So that means that my y-intercept is at the point 0, 1.2. Okay, yes, y-intercepts can be decimals or fractions. That's okay. Points can be decimals and fractions. So these would be your two intercepts. Okay, moving on to the second half. Now we're going to talk about how to graph an equation when you're in standard form. There's actually a couple of different ways to graph when you're in standard form. The way I recommend to graph, just because I think this is the way that ensures you get it correct every single time, is if you're given an equation in standard form, change the equation to a form you already know how to graph in, and that would be slope-intercept form. Okay, so we're going to look at an example next here where I show you how to do it this way. But then I'm also going to talk about another way to graph, which can be a little bit quicker in certain scenarios using intercepts. Okay, so let's take a look at number 3 here. And the first way I'm going to do this is by changing this equation to slope-intercept form. Okay, so right now we're in standard form. Remember, slope-intercept form is this, y equals mx plus b. And so basically to get this in slope-intercept form, I need to get y by itself. Okay, so I need to do two things to get y by itself. The first thing I need to do is I need to move this 2x term over the equal sign to the right side. I'm going to do that by subtracting 2x from both sides because it's a positive 2x. And so when I do that, that gives me 5y equals negative 2x plus 20. Okay, so that's my first step to get this in slope-intercept form. My second step is to get rid of that 5 right there. So that means I'm going to divide everything by 5. And remember, when you're dividing on both sides, you have to divide every term. So the negative 2x and the positive 20 both get divided by 5. So that gives me the equation y equals, this would be negative 2/5, we'll just leave that as a fraction, x, plus 20 divided by 5 is 4. So now I've put this equation in slope-intercept form, and now I know two things about this line. I know the slope, okay, because we're in slope-intercept form, we know now that the slope is negative 2/5, and we know the y-intercept from the b value there. The b value is 4, so the y-intercept has to be 0, 4. So now I can go ahead and graph this line like we've done before. Starting at my y-intercept 0, 4, I know I can go up 2 and left 5, or down 2 and right 5. Okay, and so if I go ahead and connect those dots, that's going to be my line right there. Okay, now I want to show you another way to graph that line using your x and y intercept method. So if we look at that equation again, remember we're in standard form here. Another way I can do this is I can just find the x and the y intercept just like I did on examples 1 and 2 here on the front. If we plug in a 0 for y, that's going to allow us to find the x-intercept rather quickly. We're going to get the equation 2x plus 5 times 0 equals 20, which just means that 2x equals 20, and so x equals 10. Okay, so that means that there's going to be an x-intercept at the point 10, 0, and so I can go ahead and plot that point because I know that my line is going to go through that point. So 10, 0, that's my x-intercept right there. And then I can also find the y-intercept by plugging in a 0 for x. And keep in mind, we found the y-intercept in the last problem by changing the equation to slope-intercept form. We found that the y-intercept was 4, so I should get the same y-intercept for this way as well, because again, this is the same line as the last one. We're just graphing in a different way. So this gives me 5y equals 20. If I divide both sides by 5, I do get y equals 4. And so yes, there's a y-intercept at 0, 4. Okay, so now I know the x-intercept and I know the y-intercept. If I count the rise over the run between these 2 points, this is a up 1, 2, 3, 4. So positive 4 over left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that reduces to negative 2/5. Okay, so that is the slope that we got for the last problem, so that does work out. And so I can graph one more point just to be safe by going up 2 and left 5. And that's going to be my line right there. So that's another way of getting the same exact line, okay, but by finding the x and y intercepts instead of changing the equation to slope-intercept form. The only time that this method isn't very good, the second method right here, is when your x and y intercepts come out to be fractions, kind of like number 2 did. For the y-intercept, we got a y-intercept of 1.2, then it's not going to be as simple, and so that's when I would recommend the first method. Okay, so let's look down at number 4. For number 4 here, I'm going to try that second method of finding both the x and the y-intercept right away. So to find the x-intercept here on number 4, we've got the equation x minus 2y equals negative 2. So I'm going to let y be equal to 0. And that means I'm going to get just x equals negative 2 here. So I know that my x-intercept for this line is the point negative 2, 0. Okay, so I get a whole number point for that one. And then for my y-intercept, I'm going to let x be equal to 0. So I'll have 0 minus 2y equals negative 2, which just gives me negative 2y equals negative 2. If I divide both sides by negative 2, I get y is equal to positive 1. So I get a whole number point for that one as well. So my y-intercept is at 0, 1. So now I know my line goes through those 2 points right there. So now I can just count the rise over the run between these 2 points. From the red dot to the green dot, I'm going up 1 and right 2. So that would be a positive 1 over positive 2, a positive 1/2 slope. So now I can just draw a few more points on there by going up 1 and right 2 each time. Okay, and so that would be my line here for this one. Okay, and then finally for number 5, we have the equation negative 3x plus 4y equals 10. For this one, I'm not going to use the intercept method, and here's why. If I plugged in a 0 for y to find my x-intercept, I'd get this equation. I would get negative 3x equals 10. And so solving that equation for x, you get x equals -10/3, which is going to give you a fraction, which is not terrible, but when you're trying to calculate the slope and you have a point that's a fraction, it makes things a little bit more difficult. So instead of doing this method, I'm just going to go back to that first method, and I'm going to isolate y in this equation. That's going to put the equation in slope-intercept form. So that means I'm going to add my 3x over, since it's a -3x, okay, over to the right side. That's going to give me 4y equals 3x plus 10. And then I'm going to divide everything by 4. So that gives me y equals 3/4 x plus 5/2, okay, which is going to be the same thing as y equals 3/4 x plus 2.5. So my slope for this one is 3/4. My y-intercept is 0, 2.5. Okay, so yes, your y-intercept still comes out to be a decimal or a fraction in this case, but now we know that we've tried both methods, and either way we're going to have to graph a decimal for this one. It's always just a good idea to try the other method to see if you get whole numbers. Okay, so I'm going to plot that y-intercept now at 0, 2.5. That's going to be about right here, halfway between 2 and 3. And now from that point, I'm going to go 3 whole spaces up. 1, 2, 3, so that's going to put me here between 5 and 6, and then 4 spaces to the right to do my slope of 3/4. And I'll do that again, up 3 spaces, right 4, and then back to that point I'll go down 3 whole spaces and left 4. Okay, and I'll go ahead and connect those dots. Okay, so that is how we graph in standard form, and that's how you find x and y intercepts. If you had any questions over this, feel free to rewatch those parts of the video or shoot me an email with those questions. And until I see you next time, have a nice day. You're all wonderful people. Take care.